So today we are going to learn about sine, cosine, and tangent ratios. This is 8.5 and 8.6 in your textbook. Your textbook does tangents first, then sines and cosines in 8.6. We're going to learn about them all together because they all go together. So trig ratios or trigonometric ratios, we use these to solve for side lengths in right triangles. And then we'll also use a very similar type of ratio to solve for missing angle measures in right triangles. So we've learned at this point, I think, two main different ways to find missing information in a triangle, in a right triangle specifically. Pythagorean theorem, that's great if you have two of the side measurements. We learned our 45, 45, 90 and our 30, 60, 90 rules. Those are great for those specific triangles. But what about everything else, right? What about a triangle with a 36-degree angle where we only know one of the side measurements? What are we going to do? We're going to use trig. So I have this split up into two parts. The front, we're using our basic trig ratios to solve for a side length of a right triangle if we're given an angle measure and a side length. So we have three different ratios that we're going to learn about today. We're going to learn about some other ones. It's either later in the week or next week. But these are your three most basic kinds that kind of everything else stems off of. There's the tangent ratio, the sine ratio, and the cosine ratio. So how this works is, let's take a look at the tangent ratio first. This is all done with respect to an angle in your right triangle. Not the right angle, because all of them are going to have that. So these ratios are all done with respect to one of the acute angles in your triangle. In this case, I decided to just call it a generic angle A. Okay, so they're done with respect to one of your angles. And how this works, how this ratio is set up, is the tangent of that angle, whichever angle you're provided with, equals the length of the leg opposite angle A over the length of the leg adjacent to angle A. So what you're going to do is it could be like a picture. I'm just going to kind of draw you what it would maybe look like. You don't need to draw this, but I just kind of want to show you. You would be given a triangle. You're maybe given that this is a 40-degree angle. And you have the measurement across from it, maybe that's like 7 units. And the measurement adjacent to it, maybe. So it could look, a problem setup could look something like this. Okay? But basically what we're doing here is the tangent of angle A is going to, sorry, what's it doing? There we go. Is going to equal the length of the opposite over the length of the adjacent. And how you're going to see this written a lot is tan A, where A is going to be an angle measurement like tan 36, tan 47, something like that, equals your opposite over your adjacent. You're going to see that I'm going to put O for opposite a lot, A for adjacent, H for hypotenuse. Okay, so opposite's on the other side of the triangle. Adjacent's the one that's connected to it that is not the hypotenuse. Remember, your hypotenuse is always across from your right angle. Then you have the sine ratio. So if I need to use the sine ratio, I need to either be finding or have the length opposite angle A and the hypotenuse. So you'll see this written a lot. Again, this is all with respect to whatever angle you're given. Sine of A equals opposite over hypotenuse. And either your opposite length or your hypotenuse will be missing, and that's what we're solving for. It's like setting up an equation and solving for the variable. Then we're going to have cosine. Cosine of angle A is the length of the adjacent. Oh, wait, why do I have adjacent over adjacent? This should say adjacent over hypotenuse. That's what happens when I copy and paste too much. Adjacent over hypotenuse. So cosine of A equals the adjacent over the hypotenuse. How are you going to remember these? It's a little something called SOHCAHTOA. Have you guys ever heard that before? Have you heard anyone say SOHCAHTOA? That's what this is, okay? So SOHCAHTOA is just basically a way to remember an abbreviation of all these ratios. So SOH, that's sine, is the opposite over the hypotenuse. Cosine, is the adjacent over the hypotenuse. And TOA, tangent, is the opposite over the adjacent. I write, like, if I know I'm going to have to do trig on a bunch of stuff, I write it down all the time so I can just look up at it, because it just gives you a nice little visual. And it's just a way to remember which ratio is which. You'll often use this to find a missing measurement, but also sometimes you'll just be asked to write the ratio. So that's what we're going to do first, and that's just to simply practice identifying our opposite, our adjacent, and our hypotenuse, and which one goes with which. So the first thing I like to do, it says here, use the triangle to the right to find the following trigonometric ratios and to express them as fractions. So you'll notice it asks you to find tangent x, sine x, and cosine x. So all of these ratios we're going to write are in respect to angle x. So what I kind of like to do is I like to mark what angle I'm looking at in my picture. This is just me personally. And that kind of gives me a way to easily label my picture for this scenario. This means that 5 would be the opposite, so I'm going to put an O. 12 would be the adjacent, and 13 is always the hypotenuse. But if we were looking, the reason this is important is because what if this said tangent, find the tangent of y? Wouldn't where the opposite and the adjacent be reversed? So the angle you're being asked to look at does matter with your ratios, because that kind of decides who's your opposite and who's your adjacent. So if I want to write the ratio of tangent x, I'm just tangent, if you take a look, here is opposite over adjacent. So I'm simply going to take the measurement opposite x over the measurement adjacent x. If I can reduce it, great. If I can't, I'm just going to leave it the way it is. So tangent x is the opposite over the adjacent. So that means my ratio of tangent x is going to be 5 over 12. And that's all you have to do with that one if it asks you to find the ratio. So then if we're dealing with sine x, sine is the opposite over the hypotenuse. So what measurements would I use for sine x? Braden? 5 over 13. And I can't do anything with that. That is just my sine x ratio. And then cosine. Cosine is the adjacent over the hypotenuse. So how would I write my ratio for cosine x? Adrian? 12 over 13, exactly. So that's just practicing identifying those. Now, we're actually going to apply them to find some measurements. Now, in part A here, you are given a right triangle with an angle measurement of 56. We know the hypotenuse is 19. We do not know x or y. So that means, and again, the first thing I kind of like to do is see what we have. We know the hypotenuse. We do not know the opposite. And we do not, oh no, I reversed that. But we don't know the opposite or the adjacent. I just put those in the opposite spots. I did it again. There we go. Okay. So my opposite is y. I don't know it. My adjacent is x. I don't know it. So I need to use my sine, cosine, or tangent ratios. I have to decide which one is appropriate here. And I need to solve for x and I need to solve for y. I do not care which one you solve for first. And yeah, you just basically have to figure out which ratios are appropriate. I would say pick a place to start. Let's say you want to find y. Okay, that is the opposite, right? So I'm trying to find the opposite, and the only side length I know in this picture is the hypotenuse. So if I want to find If I want to find the opposite, but I'm given the hypotenuse, do you think I should use a sine ratio, a cosine ratio, or a tangent ratio? Adrian? Sine. Because the sine ratio deals with the opposite and the hypotenuse. Here I want to find the opposite. I know the hypotenuse. So here's how you set this up. This is where that little table up at the top, what that is for. That's like your little formula. So what we do is, since we want to use the sine ratio, we write sine of 56, because that's my angle, equals the opposite measurement, I don't know it, it's y, over the hypotenuse, which is 19. So that's my sine of my angle equals the opposite over the hypotenuse. And now I just solve the equation. Think of it like a proportion. In our proportions, wouldn't we just like cross multiply? Here you can't, the sine 56 is by itself, but think of it as like being over 1. What we technically do here is we take, and I will probably never write this again, I'm just showing you for the first time you've done it. You're basically doing y equals 19 times sine of 56. Picture it like you're cross multiplying a proportion. Does that make sense? Why I'm multiplying the 9 by the sine 56? Yes? Okay. So now it's just a calculator problem. Now here's the thing with your calculator. I want everyone to hit the sine button in their calculator. What happens? Sine, and then what's next to it? A parenthesis. So if I hit sine 56 times 19, and I don't close any parentheses or I don't do anything with that, is it going to give me the right number? No. Okay, so that's, I wanted to point out to you, it gives you an open set of parentheses. So here are the two ways you could plug it into a calculator. You could either do 19 times sine 56, then that parenthesis doesn't really matter. You should get, and we are going to round to the nearest tenth. Your textbook might round to the nearest whole number. I don't like rounding to the nearest whole number. It's just not, I don't find it to be accurate. So we're going to round to the nearest tenth. This gives me 15.75, blah, blah, blah. So I'm going to say that is 15.8. Okay. The other way you could plug this in is if you do the sine 56 first, please make sure you close the parentheses afterwards. That's the important part. If you don't close the parentheses, it's going to give you negative 0.2756, blah, blah, blah. And would that be a value that makes much sense? No. So hopefully you'd catch that anyway. Braden?
My calculator does sine of these numbers. How should I?
If it doesn't give you parentheses, is it one? So you might have to type in the angle first and then hit sine. I will come look at it in just a second, okay? All right, so now let's try. Yes.
Mine doesn't have parentheses, and if I just type in sine 56 times 19, it still comes out to the 15.75.
Perfect. Yeah, it depends on the kind of calculator you're using. Some of them might require you to put the angle in first and then click sine and then multiply it by 19. It depends on your calculator. But if you're getting the same values, then you're doing it fine. Were you able to figure out how to make it work, Braden?
Yeah.
Yes? Okay. All right, so now let's look at the adjacent. Oh, at this point, could you do the Pythagorean theorem? Yes. Would I recommend it? No. Does anyone know why I wouldn't recommend it? Logan? The decimal. We have a rounded value, right? So if I take a rounded value, I plug it in and I'm rounding it again, I'm getting less and less accurate. You're going to get a much more accurate value using trig again. Plus, honestly, once you get the hang of this, it goes quite quickly. So let's now find the other one. We need to find the adjacent. So now, if I want to find the adjacent and I have the hypotenuse, which trig ratio would be appropriate? Julia? Yep, cosine. Exactly. So we are now going to use the cosine ratio. So I would do cosine of 56 equals my adjacent, which is x, over my hypotenuse, which is 19. And then you just do 19 times cosine 56. You may write it out if you want. You do not have to. So do 19 times cosine 56, and what'd you guys get? 10.6. Good. Good. People at home, are we having any calculator issues or anything like that? I'm going to take the silence as a no. How are we doing? We're seeing how to plug this in? Is it as scary as we thought it was going to be? You thought it's as scary as you thought it was going to be, Logan? Is it, did you not think it was going to be scary?
I just didn't know what was going on.
Oh, yeah, there you go. That's fair. Okay. Just most people hear trig and they go, oh, God, trig. Some of it's tricky. This stuff's not. Or shouldn't be. Oh, sorry. I have a scary profession. All right. Let's take a look at B. So for B, we are doing everything in respect to this 36-degree angle. So just good habit. Identify your opposite, your adjacent, and your hypotenuse. What's my opposite? Y. What's my adjacent? 20. What's my hypotenuse? X. Okay. So I don't care which one you want to solve for. Help me out. What could I do first? What ratio should I use? Sydney. That's okay. Okay. I like it. We could absolutely do tangent to solve for y. I don't know my opposite, but I do know my adjacent. O and A means you should use the tangent ratio. So tangent of 36 equals my opposite, which is y, over my adjacent, which is 20. Multiply that out. 20 times tangent of 36. What do we get? What was that, Sydney? 14.5. You did it. Oh, good question. So the opposite, if you take a look at your angle, right, the angle you're provided with, the opposite is going to be the side that that angle opens up to. Does that make sense? Yeah. And the adjacent is going to be connected to it. Yeah. You're welcome. Okay, so now we found y. Somebody else, how could I then find x? Brayden. Okay, yeah, I can use the cosine ratio. So that would be cosine of 36 equals the adjacent, which is 20, over the hypotenuse, which is x. What's different about this? X is on the bottom. Any ideas of how I can solve this properly if x is on the bottom? What was that? What do I divide by? Other way around, but yes. We are going to divide. Again, think of this. I'm going to show you why this works this way. Think of this like a proportion, right? If you stuck that cosine of 36 over 1 and you cross multiplied that, wouldn't you have x times cosine 36 equals 20? So then you would divide both sides by cosine 36, right? So x equals 20 divided by cosine 36. So you do divide the cosine, the trig part should go on the bottom. You don't have to write that out every time. You will eventually recognize, oh, my variable's on the bottom. I should divide instead. So 20 divided by cosine 36, and we should get 24.7. Now here's the other nice thing about this. Should you kind of be able to tell if you have reasonable values or not? For the most part, right? If you're getting really really small or really big values or weird decimals, then that should kind of tell you something. Also, if you're not confident about it, it's a right triangle, right? Could you plug it into the Pythagorean theorem? Will it be a slightly off because of the decimals? Yes, but will it at least give you an approximation? Yeah, it'll at least kind of tell you if you're totally unsure. But try out C, try to set up your ratios, and then I'd like to hear from some people. So people at home, you're trying out C. Let me take a look at what exactly is happening. Okay, so here's what you're gonna have to do then. So what you're gonna have to do, Brandon, so when you plug some of these in, you're gonna have to type in the angle first, right? So if you wanna find the tangent of 36, you're gonna have to do 36 tangent, like that, okay? So what you can do here is you do your 20 divided by 36, and then don't like to equal or anything, hit cosine, and then hit equals, okay? So it needs to like know the angle first, and then know what trig ratio you want to use. Is that okay? Okay. Let me know if you have issues with that. You got a nice calculator. Everyone should get one of those. It's the same one that Matt has. It's like the best, like, simple calculator without having to like get all the fancy graphing stuff. All right. Ashley, what was my opposite, my adjacent, and my hypotenuse in part C? Yep, opposite is 16, adjacent is y, hypotenuse is x. Matt, tell me one of the equations you set up for this problem. Yep, sine of 70 equals 16 over x. It's sine of 70 equals your opposite, which is 16, over your hypotenuse, which is x. And then how'd you go about solving this one? I'm confused. X is on the bottom. Yep, good. So this one we got to turn into division. 16 divided by sine of 70. And what did you get, Matt? Like a clean 17? Like 0.0 something? Oh, yeah, that sounds good. Yep. So 17.0, or just 17, 17.0, whichever you prefer. I do not care. How about for A? Ella, what do you think? Repeat that for me. Tangent 70 equals, yep, 16 over y. Sounds good to me. We would turn that into division, right? Yeah, so y equals 16 over tangent 70. What'd you get, ma'am? 5.8? Let's see. Yep, 5.8. Good. Questions, concerns? People at home, questions, concerns? How are we doing? Are we okay? Brianna, you good? You sure? You positive? What kind of calculator do you have? Oh, you have one of those? So I will come look at it. I have to see it. Okay. So give me just 1 second. I'll come back and look at the division. Each one of them's a little bit different. I don't know until I look at it. People at home, are we all good with our calculators?
Yes.
Okay. Let me know if you're not getting something correctly or you can't figure out how to plug it in, because each calculator is a little different. And if I ever say in your calculator, it's because I'm talking about the ones I have in class. Okay, inverse trig ratios. This is explained differently in your textbook. I'm just letting you know. Your textbook does not refer to these as inverses. What we do with our inverse trig ratios is we're finding angle measures given two side lengths. So there are problems that you're asked to find angles in this section of your textbook. It's just set up slightly differently. What they do is they set up your angle as like an unknown, and they want you to solve it differently. They want you to use your table. The table, I think, Why use a table when you have a calculator? Personal opinion. Okay, so, and honestly, this is just as easy. So inverse trig ratios are used to find angle measurements given two side lengths. So inverses, we are literally just taking what we're doing, switching things around to find an angle measurement. This little -1, see how it says tangent -1? That means inverse. That is the mathematical kind of labeling for inverse. So this would read inverse tangent. You use the leg opposite angle A over the leg adjacent angle A, because tangent is opposite over adjacent, equals your angle measurement. How it kind of works is before we knew our angle, right? So we plugged it in. Here, this time we don't know our angle, so we plug in our side lengths. So what this would look like is inverse tangent of the opposite over the adjacent equals your angle measurement. So we plug in our sides to find our angle. Inverse sine, so to find an angle, if we have the opposite and the hypotenuse, we would do inverse sine of the opposite length over the length of the hypotenuse equals the measure of our missing angle. And then for cosine, inverse cosine of the adjacent length over the hypotenuse equals the measure of our missing angle. These are all still done with respect to an angle, but in this case, it's whatever angle you're looking for, rather than whatever angle you're given. So if you look at part A here, we have a missing angle measurement, but I have two sides. So you still kind of do the same thing, where you're looking at this with respect to your angle. 13 is on the opposite side, so 13 is your opposite, and 25 is your adjacent. So the other thing that's nice is SOHCAHTOA also still applies. So that's nice too. So if you have your opposite side and you have your adjacent side, which ratio would we use? Tangent. This time we're trying to find an angle, so we just have to use inverse tangent instead. So how you would set this up is inverse tangent of your opposite length, which is 13, over your adjacent length, which is 25, equals basically our missing angle measurement. And then from here, it's literally just a calculator problem. You just plug it in. So if you take a look, if you're using one of these, if you're using a TI-30X2S, if you look above, sine, cosine, and tangent, do you see the little inverse sine, inverse cosine, inverse tangent? It should look like this on the multi-view as well. For that, to get up there, you use the second button. So you hit second, you hit second, and then tangent, and it should pop up as inverse tangent with the open parentheses, just like before. Do we see that? And then you're going to plug in 13 divided by 25. You can close your parentheses if you want. Since you're not plugging anything else in, it's not a huge deal if you do or you don't. Hit enter, and you should get that your missing angle is 27.5. I also like to round to the nearest tenth with these.
Question.
Yes.
I got 3.
Okay. Let's see what happened. I wonder if...
Do I have to put the 13 and the 25 in the parentheses since mine doesn't have parentheses? Should I like parentheses?
Okay, so if yours does not have parentheses, what you probably want to do, David, is first divide 13 by 25.
Okay.
And don't clear it out or anything. It should give you 0.52.
Okay.
And then hit your inverse tangent, and then hit equals. Tell me if that works.
Oh, okay, there we go.
Did that work?
Yeah.
So, Braden, it would be the same thing for you?
Yeah, I actually did it ahead of time and thought that I got the right answer.
Perfect, yeah. So you simplify the fraction first, then your inverse tangent. Brianna, how's your calculator going? That one you could figure out? Okay. Anyone else? Julia? What kind of calculator do you have? Oh, you have, yep. I'm going to have to come look at that. I have no idea what kind of buttons are on there. like that feeling I get the right answer, but like that's not working this time. I will have to look. Okay, I will come look. Anyone else at home? Oh, the other thing is too, is we won't use radians in this class, but if you look down at the bottom of your calculator, depending on what it is, see how like mine says DEG down at the bottom? You guys have that on your display screen? You might not on a multi-view, but on one of these, it should say DEG. That means your calculator's in degrees. You want it to be in degrees, not in radians. Radians, we don't do in this class, but you will use them in trig. That's when you do like unit circle stuff. Okay, so just it could be a setting issue if you're like, no, this is the way I did it last time. It could be a setting issue. If you ever need to clear it out, you can always reset it on the back if you need to. Okay, let's look at B. Then I'm gonna have you guys do C, and now Julie, I'll come help you. Okay, so for B, here's our angle. Brock, what do we have? Do we have the opposite? Do we have the adjacent? Do we have the hypotenuse? I'm putting you on the spot. What's 39? The opposite, the adjacent, or the hypotenuse? Take a look at the angle that you're being referenced to. Is 39 across from it or next to it? Next to it. So it would actually be the adjacent. Yeah. And then what would 54 have to be? The hypotenuse. So if I have the adjacent and I have the hypotenuse, then Sebastian K, which ratio should I use? Cosine. Yep, and we're looking for an angle, so this is going to be inverse cosine of 39 over 54. I'm just going to put equals question mark. You can do it all in one step if you want. So inverse cosine 39 over 54. Logan, what'd you get? 43.8 degrees. Good. Try out, see if you haven't done it already. While I look at Julia's, I don't know, insane computer. Her Tesla, they have her Tesla.
Yep, mine was accent.
Oh, it's just like a typically adding the time. We might have to well, we got the middle school, like, my teacher got a trial for these, and that's how, like, me and one of our teachers had, so we got them. We had to, like, use YouTube on how to do them all, yeah, we will have to look up how to fix that. So, yeah, Google it. Because I know that. All right. All right, part C.
Wire.
Yes,
I'm not
Sarah.
getting 43.8 for some reason.
Did you do 39 divided by 54?
Yeah.
Did you clear it or did you not clear it?
No, I still had it in there as the answer.
Okay, and then you hit inverse cosine?
Yeah.
What are you getting?
Well, hold on. Oh, it was stuck on I had to hit the shift. My calculator is weird. I have to hit the shift button again to get it unstuck.
Oh, okay. You're all
Yeah.
good now?
Yeah, I'm good now.
Technical error. Okay. All right, part C. Ooh, who shall I pick online? There's just so many people at home today. Caleb, what do I have? The opposite, the adjacent, the hypotenuse? Question mark? Caleb? Oh no, we don't know where Caleb went. Lucas, what do you think? 20 and 22, what do I have? The opposite, the adjacent, or the hypotenuse? Or which combination of the two?
You have the hypotenuse and the opposite.
Yep, 22 is the hypotenuse, 20 is the opposite. Great. So Hillary, which ratio should I use? Sine, cosine, or tangent?
Sine.
Sine. Yep, we are going to use our inverse sine tangent. Plug in your 20 over your 22. And we are going to simplify that to get inverse sine 20 over 22. We should have gotten approximately 65.4. Is that what we got? Excellent. That is a awesome way for right triangles. If you are given this information, this is all you need for right triangles. But is every triangle in the whole wide world a right triangle? Oh no, it's not. It won't be our problem today, but guess when it will be our problem? Thursday, actually. Thursday.